So this is box B here, derivatives of exponential functions. So if you watch the lesson for part A, we've already gone over this a little bit, but we know that if our function is e to the x, our derivative is also e to the x. So this is sort of the simplest derivative rule that you're going to have to know. Okay. Where it becomes tricky is if your function is a composite function. So instead of just e to the x, you have e to some function of x. We'll just call that g to the x. In this case, we have to use the chain rule. So our derivative is going to be our original function. So it's our outer function is e to something, which is just, again, e to something. So we do our original function, e to the g at x. Okay? And then we multiply that by the derivative of our inner function, which is g of x. So we just multiply this by g primed at x. Okay? So it's our original function, whatever we see, multiplied by the derivative of what is in the exponent. Okay? So let's take a look at a couple of examples here. First one here, y equals e to the 5x. If we want to go through the steps here, this is obviously one where we have to use the chain rule. Our function g of x, which is our inner function, is just 5x. So our derivative, y primed, is going to be our original function, e to the 5x, times g primed at x, or the derivative of what's in the exponent. Derivative of 5x is just 5. So this is going to be times 5. All right? So this is 5e to the 5x. And because exponential functions have this property where the original function always appears in the derivative, you're sometimes asked to express your derivative in terms of the original function. So our original function here is e to the 5x, which appears right here. That's just y. So we could also write this as 5y. Okay? Just identify where the original function appears and sort of write that in. All right, so let's look at next example here. Give myself a bit more room. All right, our next function here is y equals 7e to the x squared. Again, we're going to be using chain rule. Our inner function, g to the x, is, well, it's what's up there in the denominator, x squared. So our derivative is going to be, let's see, 7e to the x squared, so our original function, times the derivative of our exponent there, or our g to the x. So derivative of x squared is just 2x, so it's going to be multiplied by 2x. And then we can simplify this. 14x e to the x squared. Or, if we wanted to express it in terms of y, doing that, y was 7e to the x squared, so we've got y right there. This would be 2xy. Our last one here, where we start to get a little bit complicated. 6x to the power 4 times e to the 3x plus 7. Okay. What are we going to need to do here? What rule are we going to need to use? Yeah, product rule and then the chain rule to do the derivative of that exponential function. Sorry about that. So let's start by, well, let's just identify what our two functions are going to be here. We'll call this one u, we'll call this one v. And if we're going to do product rule, remember that it's derivative of u times v plus u times the derivative of v. So our derivative of u, this is just power law here, so we get 24x cubed. Multiply this by our v function, 3x plus 7, plus our original function here, our original u, so 6x to the power of 4, times, what is the derivative of v going to be here? V is an exponential function, so we're going to have our original exponential function, 3x plus 7, times the derivative of what's in the exponent, which is just 3. Okay. So now we should look at what's common to these two terms and try to factor it. So we can definitely factor out e to the 3x plus 7, which is going to leave us with 24x cubed plus 18, because that 6 gets multiplied by the 3, 18x to the power of 4. Okay? And is there anything else we can factor out now? Richard? Yeah. So we can do 6x to the power of 3, e to the 3x plus 7 times 4 plus 3x. Okay. Which is our derivative there. If we wanted to write this in terms of the original function, our original function was 6x to the power of 4, e to the 3x plus 7. We've got 6 to the power of 3, e to the 3x plus 7 out front. If we were to, now, I mean, you would stop there unless it told you to write it in terms of y. If it did tell you to write it in terms of y, you would, you need another x there. You need this to be 6x to the power of 4, e to the 3x plus 7. But if I've multiplied that by x, I also have to divide it by x. So those two, the x's, when I did that division, would give me the x cubed back. And this would still be times 4 plus 3x. So this thing up here in the numerator is my y. So this would be y over x times 4 plus 3x. All right. So let's take a look at an example, sort of an application type question here. Find the equation of the tangent to y equals x e to the minus x at x equals 1. Okay. So this is the kind of question that you've done, I don't know, at least 20 times by now in the course. Okay. Finding the equation of a tangent to simplifying. The only difference is what derivative laws we have to apply. So what's our first step in a question like this? Determine g at x. Okay. So we've got g at x equals negative x for our exponential function. What else do we have to notice about this function that we're given? What rule are we going to have to use when we're doing this derivative? Chain rule and the product rule, because it's x times something. So let's get our derivative here. Y primed is going to be derivative of this, which is just 1 times our second function, plus x times the derivative of e to the minus x. So that's going to be e to the minus x times the derivative of g to the x. So g to the x should be negative 1x. So we've got to multiply that by negative 1 there. And then we can simplify. E to the minus x minus x e to the minus x. Have I done this correctly? Okay. Where do we want to go from here? Okay. Now what do we want to do? Yeah, we want to evaluate this at x equals 1. Derivative gives us the slope of the tangent, so we want the slope of the tangent at x equals 1. So at x equals 1, y primed is going to equal e to the minus 1 times 1 minus 1, which is 0. So what does this tell us about our tangent line here? It's non-existent?
No, it's horizontal.
It's horizontal, yeah. Yeah. So it's horizontal. Okay, so now what else do we need to do if we're going to get the equation of this thing? Okay. We can put in our slope is 0. So y is just going to be b. How do we figure out b now? So go back to our original equation here. So we've got y equals x e to the minus x. If x equals 1, this is 1 e to the minus 1, which is just going to be 1 over e. So if y equals 1 over e, that's going to be our equation. I mean, we put in y equals 1 over e. That tells us that b is 1 over e, so y equals 1 over e is the equation of our tangent. Okay? This is the equation of a horizontal line because it's just y equals a constant.